Dilution occurs when a drug-free diluent is added to a drug preparation. The added diluent increases the total amount of drug preparation, so increased solution quantity, but it makes the drug within the preparation less concentrated as the drug becomes dispersed through the larger volume, so lower drug concentration. Adding water to a drug solution is one example of dilution. So this water being added to pink solution, it increases the total volume and it decreases the concentration of pink chemical in solution. It's like adding water to your orange juice. You increase the total amount of orange juice, but the result is weaker and may not taste as good. You can also dilute non-liquid drug preparations. For example, if you have you could add more inactive powder to dilute the drug, or you could add a ointment gel base to a drug gel preparation. And in those situations, you have the same situation that results. A greater amount of gel base, for example, that has a lower concentration of drug. When solving dilution problems algebraically, we usually start by calculating the total amount of drug. Because the amount of drug doesn't change during a dilution, we simply make it less concentrated by adding more diluent. So for example, how many mils of 15 mg per mil drug solution should be diluted with water to give 100 mils of 5 mg per mil solution? So we can see this is a dilution because we have a higher concentration here and we're going to a lower concentration after dilution. But both solutions have the same amount of drug in them. It's just the amount of diluent that changes, or the total solvent volume. So we can use either one to determine how much drug is in the solution. So we have a quantity and a concentration for the 5 mg per mil solution. So let's go ahead and use that. There's 5 mg per mil. We want to know how many milligrams are in 100 mils of the solution. We can cross multiply and we see that there are 500 milligrams in the 5 mg per mil solution. And there will be the same number of milligrams in the 15 mg per mil solution. So we can ask how many mils of solution are used to dilute that 500 milligrams into 15 milligrams per mil concentration. So cross multiplying, dividing both sides by 15, we see that 500 milligrams will be in 33 1/3 milliliters when it's at a concentration of 15 mg per mil. So reading the problem again, how many mils of 15 mg per mil drug solution should be diluted with water to give 100 mils of 5 mg per mil solution? The answer is we'll have 33 1/3 mils of the 15 mg per mil solution and then dilute that with water up to 100 mils, and the new concentration at that point will be 5 mg per mil. In the second example, what concentration will result if 40 mils of water is added to 100 mils of 14 mg per mil drug solution? So again, we'll start by calculating the drug amount given the quantity and concentration of the drug solution. We have 14 mg per mil. We want to know how many mgs are in 100 mil. We cross multiply and we see we have 1400 milligrams. We can take that 1400 milligrams and divide it by the new diluted volume, which is the 100 we started with, plus the 40 mils of water we added to give a new solution volume of 140 mils. So 1400 milligrams divided by 140 mils gives 10 mgs per mil. So if we added 40 mils of water to 100 mils of 14 mg per mil drug solution, our new drug concentration would be 10 milligrams per milliliter. If we note where concentrations and quantities appear in the algebraic solutions, for example by using a C for every time there's a concentration, and using a Q for every time we have a quantity, certain patterns appear. So in the first step, we multiply a quantity and concentration together to get a total drug amount. In the second step, we divide the total drug amount by a concentration to get a quantity, in this case, or we divide by a quantity to get a concentration, in this case. These algebraic steps have a pattern that allows us to come up with a shortcut equation for solving dilution problems. So the equation on this side says that the concentration you start with multiplied by its total amount, or quantity, will equal the concentration you end with multiplied by its total amount, or quantity. Please note that the quantity Q is the total amount of preparation, which, as we saw already when doing constitutions, is equal to the amount of diluent plus the amount of drug or any other ingredients. You also need to know that just like when you solve problems algebraically, if you use this formula, you need to make sure that you use the same units of measure for all quantities and concentrations. In other words, you can't measure one quantity in milliliters and another in liters. So in the first of the example calculations, if 200 grams ointment base is added to 1,000 grams of a 10% weight per weight ointment, what is the new drug concentration? So if we use the formula, we would put the quantity and concentration together, and it really doesn't matter which QC you put this into, but we'll call this Q1 and we'll call this C1. So 1,000 grams of 10% weight per weight ointment, and then we have a second quantity and the concentration we're looking for. We want to find the new drug concentration if we add 200 grams ointment base to 1,000 grams of the 10%. So that means, again, remembering that the Q is the total quantity, that means that we have 1,000 plus 200. So plus 200. So 200 doesn't go in here. It's 1,200 that goes in because we'll have 1,200 total grams of the new concentration. So we multiply 1,000 times 10. We divide by 1,200. And because our original concentration was at 10% weight per weight, the answer will also be 10% weight per weight. 8.3. How much ointment base should be added to 1,000 grams of 10% weight per weight ointment to give a drug concentration of 5% weight per weight? So we have the same quantity and concentration we did before, which we can put in here. So 1,000 grams of 10%. And this time we're looking for the total quantity of this new concentration, 5%. So how much 5% will we have, and how much ointment base should be added to get that concentration? So we multiply 1,000 times 10, we divide by 5, and we see that we'll have 2,000 grams of 5% ointment that results. Well, the question isn't how much 5% will result, it's how much ointment base should be added. And so we have to look at the difference from where we started to where we ended, and that's the amount of base we added. So we ended with 2,000 grams of 5%, we started with 1,000 grams of 10%, so the difference is 1,000 grams, so that's the amount of ointment base we add. All right, go ahead and try the next slide of problems, and I'll work them out in the next video.